Welcome to our lecture online, and now let's take a look at the surface temperatures of the 8 planets in our solar system. Again, as a comparison, we have the terrestrial planets and we have the gas planets, and the obvious difference is the gas planets, the temperatures within the atmosphere of the gas planets is far below the typical temperatures that you'll find around the terrestrial planets. Now, the variation in the temperature of the terrestrial planets has a lot to do with the amount of atmosphere, or for that matter, the lack of atmosphere. In the case of Mercury, of course, there not being an atmosphere, during the daytime temperatures will reach as high as 350 degrees centigrade. And that's, of course, because it's so close to the sun. And the days on Mercury are so long that about 115 days for a 24-hour period on Mercury, you can see that the temperatures are very, very high for a very long time. But then when the nighttime comes and lack of atmosphere, the heat readily radiates back out into space, the temperatures will drop to as low as minus 170 degrees centigrade. If you like Fahrenheit degrees better, that's all the way from 662 degrees Fahrenheit during the daytime all the way down to minus 274 degrees Fahrenheit at night. A tremendous shift in the temperature between day and night on Mercury, the largest temperature difference of any body in the solar system. Now, Venus has a unique situation because of the enormously thick atmosphere, 90 times the density of the atmosphere on the Earth. You can see that the temperature remains 460 degrees centigrade year-round, winter, summer, night, daytime makes no difference at all. Anywhere on the planet, the temperature is roughly 460 degrees centigrade, which is 860 degrees Fahrenheit, hot enough to melt lead. And the fact that it stays consistent like that is absolutely enormous. So it's not a good place to spend your summer vacation unless you bring a lot of insulation, because under those temperatures, it would be enormously difficult to land anything on the planet and have it survive. The Russians did once. They actually physically landed a satellite onto the surface of Venus, and it lasted for about 20 minutes before the heat and the pressure totally broke it down and it stopped working. So we have just a few pictures of what it looks like on the surface of Venus, and you can see why it would be so difficult to do so. The Earth is in a unique position, the right distance away from the sun, with temperatures varying from 60 degrees centigrade at the very hottest place to minus 90 degrees centigrade at the very coldest place in the wintertime. This would, of course, be the Antarctic, and this would be one of the deserts on the Earth. The hottest temperatures ever recorded on the Earth was 134 degrees Fahrenheit, which was in modern times. That was back in 1913 in Death Valley, California. But we can say that the temperature probably has gone as high as 140 degrees Fahrenheit on the Earth, and it goes down to as low as 130 degrees below zero Fahrenheit in the Arctic regions, especially the Antarctic, where it gets really cold. When we go to Mars, you can see here that the temperature barely breaks the freezing point during the daytime in the summertime near the equator, and goes down as low as minus 140 degrees centigrade at night and at the polar regions. So you can see that there's enormous temperature shift on Mars, and at the coldest periods it's extremely cold. It is so cold that the carbon dioxide atmosphere will actually condense and precipitate in solid form onto the surface, forming a layer of carbon dioxide frost in the wintertime on Mars. When we go to the gas planets, notice that the temperature in the atmosphere in Jupiter is minus 180 degrees centigrade. That's extremely cold, minus 162 degrees Fahrenheit. What we find, however, though, on Jupiter is that the temperature should actually be colder. With the amount of heat that Jupiter receives and the amount of radiation that should go back into space, the temperature of Jupiter should be probably about 5 degrees centigrade colder than it actually is. And what we discovered was that Jupiter is still expelling heat from its initial formation more than 4 billion years ago. When the planet condensed and contracted together, there's still the leftover heat from the interior that heats the atmosphere up just a little bit more than it should be if that heat wasn't there. We then have Saturn being about twice as far away from the sun as Jupiter, temperatures in the atmosphere minus 180 degrees centigrade or minus 292 degrees Fahrenheit. And Uranus and Neptune go down all the way to minus 218 degrees centigrade, which is only 55 degrees Kelvin above absolute zero, temperatures about minus 360 degrees Fahrenheit. Now we say, well, why would Neptune, being so much farther from the sun than Uranus, be about the same temperature in the atmosphere? Well, it has to do with the composition of the atmosphere. There's more there's more methane in the atmosphere of Neptune, and therefore it absorbs a little bit more of the sunlight and keeps the atmosphere relatively a little bit warmer than it would be if it didn't absorb that additional heat from the sun. But yet at minus 218 degrees centigrade, we really shouldn't be talking about heat. That is frigidly cold, and no way for us to survive, of course, in that kind of environment. So that gives you a pretty good feel for the different temperatures. Notice that a planet having an atmosphere will be either very consistent as a gas planet, very consistent as Venus, or will moderate the temperature, like on Earth and Mars, relative to the enormous temperature swings on Mercury, where there's no atmosphere at all. That's the explanation for the atmospheres and the accompanying temperatures on the planets.